Well, I guess it's still technically morning. Good morning, almost afternoon, everyone. Thank you all for trekking all the way down to this side of the world to hear our presentation. So, my name is Kenneth Smith. I'm the industry principal for Hortonworks for energy. So I look after both oil and gas as well as utilities. And you're going to get some insight today around one of our customers, Centerpointe Energy, and their data journey and their architecture. But before we get into that, I'd kind of like to talk a little bit about what we're seeing in the industry. I know we've got a number of utilities here in the audience, which is great because it's highly applicable to what you're going through today. So I'm probably telling you things that you already know, and you know them way better than I do. But essentially, there's a ton of disruption. I'd argue that the utility industry is experiencing, as much or more disruption than, many other industries, right? Obviously, the compelling event somewhat is occurring around smart meters, where just the volume velocity of data is, increasing exponentially, and ultimately there's a lot of discussions on the value and the benefits around smart meters, to the customer, not just to the utility provider, right? And delivering additional value and helping consumers ultimately have power to choose, different options around, reducing their bills and, optimizing how they consume energy. So, obviously data growth, very similar to oil and gas. A lot of the infrastructure, it's been out there, for a while. John Presley, he just walked in right here. Spoke at our breakfast this morning around, age of transformers, and ultimately, dumb equipment that doesn't tell you when it needs to be replaced. So ultimately, how do you take, advantage of historical maintenance history and, the different telemetry equipment, kind of throughout that value chain to identify, when to actually, optimize the life of that equipment and substations and everything else through data, right? So aging assets, similar to oil and gas, right? Crew change occurring. So ultimately, how do you leverage data and analytics to, empower a younger workforce and really kind of, extract that knowledge from experienced folks and, build in automated workflows, things like that. Regulatory pressure, obviously, for y'all is huge in the utility space. And then, this whole concept of, distributed generation and alternative energy sources around solar and wind and storage and, prosumers, right? They're not just consumers. In many cases, they're actually generating and desire to, put energy back, onto the grid and offset energy costs. And all of this, right, is just driving innovation in addition to, I kind of allude to the, McDonaldization of the world and everyone wanting information at their fingertips. So the customers have become, much more demanding around, being able to see in near real time how much data or how much energy they're consuming. And so really the opportunity lies with big data, advanced analytics, and harnessing all these different data sets, ultimately driving value for not just for a utility to increase operational efficiencies, lower costs, and increase revenue, but as well as keeping customers happy, which, as we all know, is not necessarily easy because we're all consumers and we all have our own demands and all that good stuff. So no surprise, smart meters are on the rise. This is a particular, it's a Bloomberg report that just shows globally, right, the growth around smart meter deployments and just the amount of data, right? So according to this, it's a Capgemini. It's a really good piece on big data blackout. 280 petabytes of data, will be generated annually by this year, end of this year. I think that figure's actually probably gone up a little bit depending on what analyst that you read. And so, again, how do we go and, it's great that we can generate it. It's great that we can collect it, but how do we, drive value out of it? And, not coincidentally, spending is on the rise from an analytics perspective. So we're members of Utility Analytics Institute. It's amazing to hear the stories, right, of different utilities and where they're at in their journeys. But at the end of the day, spending is continuing to increase across power and utility providers And some of them are a little more focused maybe on customer analytics, some on operations. Obviously from a forecasting perspective, that's a big challenge, right? Out here especially, I mean, there's probably not another state that's experiencing more disruption than California. When you look at, just from a regulatory standpoint, the desire to move to clean energy, electric vehicles, you don't have to tell anyone that you buy an electric vehicle. And so Tom Martin's a really interesting guy from PG&E. He's part of their innovation team, and he talks around just how the duck curve, right? It's flipped. And what used to be at night, people turn lights off and they go to sleep, and so you see a huge drop in demand, and now it's the opposite, right? Because people are plugging in their cars. So ultimately, how do they find out who has actually purchased a vehicle so that they can plan for that, right? Not just from a delivering power perspective, but as they continue to look to add infrastructure and all that. And lastly, it's not just around smart meter data, right? The utility industry has a ton of both structured and unstructured data sets. And ultimately, the desire to leverage a platform like Hadoop and other open source tools to aggregate all of these different data sets into a single environment, ultimately drive intelligence and analytics and business intelligence. And that's really just some of the use cases, obviously, that we're seeing today. John spoke about a number of them this morning, but RevPro, single view of a customer, right? Looking at building out propensity models for new marketing initiatives around next best action programs and things like that. And of course, forecasting is a big one. How do we plan for this? What used to be a very linear one-way flow of power generation through delivery to now it's just this big mess, right? It's all over the place. And we have gas plants, we have nuclear plants, we have wind, solar, distributed generation, all that good stuff. So with that being said, I'm honored to have Daniel here from Centerpointe that's going to talk a little bit around their journey. I think this is a great story about integrating two very prevalent technologies, legacy technologies from companies like SAP, along with new open source tools from Hortonworks, and how they're taking advantage of that combined ecosystem to drive value through advanced analytics and data management. So, that being said, I'll turn it over to you, Daniel.
Thank you. Can you hear me? Yeah. Okay. As Kenneth said, my name is Daniel Sunders. I am an enterprise architect at Centerpointe Energy, and I've got about 15 to 20 minutes worth of content, so there should be some time for questions at the end of the presentation, so feel free to interrupt me during the presentation, but obviously we'll have time at the end as well. So during the presentation, there's a couple things that I'll first start off by giving you a brief overview about Centerpointe Energy. I'll talk about the business challenge that led us to implementing HDP, the architecture of our current analytics organization, some particular use cases around smart meters, which is, as you'll see, was kind of the big business driver to go with HDP, and some other initiatives we're starting to dabble with outside of what I would call traditional analytics. So who's Centerpointe? Centerpointe, we've got two main lines of business. The first one is we own the electric and transmission distribution lines within the greater Houston area. So we have about 2.4 million customers. We don't sell electricity. We don't generate electricity. We just charge a rate for moving it. And then our other major line of business is our natural gas and distribution. And as you can see on the map, we operate in about 6 states. So I guess some other high-level stats to throw. We have about $22 billion in assets and roughly around 7,700 employees. So what was the business challenge? Why did we implement HDP? The first one, really the main reason was our smart meters. We've recently have, in about 2012, fully deployed our smart meters. And we have roughly 2.4 million customers, and basically what a smart meter is it's going to take a reading every 15 minutes of how much energy a particular household is consuming. So if you kind of do the math, we have 2.4 million customers. It's going to generate 96 intervals per day, and we have, if you look at maybe 365 days in a year, that's a little over 80 billion records that we're going to be storing, at least from a interval consumption perspective. These devices do collect a lot more data than this, but this is the largest one. And so that's a little over 800 billion records a year. And if you do the math, since we have a regulatory requirement to keep the data for 10 years, it's going to be approximately a little over a petabyte worth of data. So we knew with our current analytics technology that this is something that we were going to have to kind of think outside the box for and look for different solutions, as it wasn't feasible to store it in the appliances that we had previously. So with that being said, we had an initiative to form what we call our advanced data management platform. And really, the vision for it is obviously it needed to be scalable. We needed to be cost effective. We wanted to make sure that the data resided in the tier that was appropriate. So data that is queried often, we wanted it to be in memory, and data that wasn't queried quite as often or were suitable for long-running batch jobs, it would be in a lower tier storage. Obviously, since we were already doing real-time reporting, we wanted to be able to continue to do that. It needs to be reliable. And we wanted to be able to lay a foundation to support for future use cases such as cognitive computing and machine learning. So what did we implement? We implemented a combination of SAP HANA and HDP. And so with this being a Hortonworks conference, I really won't get into the HANA side of things, but just high level, it's a multi-tenant environment where we've got BW and HANA, and we've got native HANA tenants, one of them being specifically smart meter data. Over here on the right, we implemented HDP. Our cluster today is 24 nodes in production. It's 24 in QA and 9 in development, I believe. And for visualizations, we're using a combination of Tableau and SAP Business Objects on top of both environments. So kind of circling back to smart meter data, how do we get the data from our MDM transactional system into SAP HANA and then eventually into HDP? So at least the first portion of this from MDM into HANA, we're using data services. This is we did look at real-time technology for this, but we didn't really have a real-time requirement yet. And due to cost, wasn't going to be, wasn't really worth going the real-time route. So we have a batch, it loads 3 times a day. And then pushing data into HDP, we've used Scoop. And basically, after 13 months, we aged the data from HANA to HDP, specifically Hive. And we chose 13 months because lots of times we get many updates in each batch to these intervals. So we get thousands of updates. And we wanted, after 13 months, about 99.9% of those updates have stopped occurring. So we didn't really have to design a robust process within Hive to handle a whole bunch of updates. And then we load master data into HDP using Scoop, and we're also loading it into HANA using data services. So kind of circling into what we designed on the Hive side is, since like I just mentioned, we had to be able to support updates, we implemented transactional tables. These tables are bucketed and partitioned as required for a transactional table. But we quickly learned that Scoop doesn't allow you to directly insert into a transactional table. So we staged the data, and then before loading it into the transactional table, we actually sorted it. And we noticed about a 33% performance gain on the majority of our queries by sorting the data before loading it into the transactional table. From a bucketing and partitioning perspective, we settled on daily partitions with 8 buckets, and we really tackled this by just kind of brute force testing different combinations, seeing kind of what fit best for both loading data into the transactional table and also querying it. And I guess from the bucketing perspective, we noticed that the larger number of buckets, the faster we would be able to insert into the transactional table, but also that was going to be generating a large number of files, which really isn't ideal, small files, which really isn't ideal because it doesn't align with your HDFS block size. So we basically kind of settled on this as it was closely aligned from an HDFS block size perspective. And performance-wise, we were kind of getting what we expected. From a master data perspective, we have our master data tables bucketed the same way that we have our transactional tables. So when we actually join these two together, we're able to take advantage of performance gains between the two. From a storage perspective, we're storing everything in ORC format. And I was actually present very surprised, at least, of the compression we got from an org perspective. We're actually getting around 30x compression, which kind of blows away what we were getting previously in Netezza and now in HANA. They're both about 10x. So I guess if you do account for the 3 times replication, it's sort of around 10x, but really I was pleasantly surprised with the compression we got with org. So now that we've got the data in HDP, how are we using it? Well, the first business case that we're tackling, and we've done a prototype previously and we're going to be implementing in the near future, is something that we've called or coined our forecasting model engine. And this is basically how does weather correlate to load, both in a short-term perspective and in a long-term perspective. Short-term being, hey, you know, temperature's 100 degrees, 90 degrees, 105, what is it going to do to my load? And this is probably what I would call, you know, kind of the low-hanging fruit. It's really easy to tackle, but long range is, you know, what does my weather response function look like 5 years from now? Because you know, we have industry trends that are happening, such as, you know, more efficient air conditioning, and you notice that your load is not going to be impacted. You know, you may not have quite the uptick that we used to have when, you know, you have a really hot summer, right? So you kind of have to look to see what are the industry trends going on and what do you expect your weather response function to look like 5 years later. So this is a process that we're going through right now, and now that we have HDP, we'll be able to tackle this looking at a lot more data. Another big use case for us is diversion, and this is just simply a customer diverting their meter to steal electricity. So for us, previously we had tackled this a lot with meter events. Basically, hey, a meter's been tilted with a combination of another items. It's likely that diversion might be going on. Of course, we have to correlate, you know, with meter events with, hey, your meter was tilted. Do you recently have a technician there? Let's merge those data together and say, oh, hey, a technician was there. It's not diversion. It's the technician. But if there wasn't, okay, let's go investigate this premise. But we're constantly, you know, looking to try and to improve our accuracy from a diversion perspective. So one of the ways that we're looking to tackle this is by incorporating interval data into this process. So the way we're going to try and do this is a lot of customers have, or diversion, I guess customers have particular load shapes that are prevalent for diversion occurring. So if you get a combination of some meter events that are saying diversion's likely happening and the load shape looks funky, then you're probably going to, we need to roll a truck and we can improve our accuracy. It's key for us to have the best accuracy that we can, because obviously every time we roll a truck and diversion's not actually occurring, it's costing us money. So this is something that we're constantly looking to improve, and a project that's actually about to kick off within the incorporate interval data within the next month or so. A couple other areas is a usage history portal. We have a portal that sits on top of this data that allows both internal and external customers to view their interval consumption. This will be both for, you know, a residential customer might be interested because they want to know, hey, does this free nights and free weekends plan make sense to me? And obviously we have internal clients that are very interested in the data as well. Another big one is transformer load management, as Kenneth hit it on just a second ago. Basically for us, what this is you're aggregating interval data at an individual transformer, and you're seeing, hey, is it overloaded now? Do we need to look at potentially replacing this asset? How do I shift load to potentially decrease the load on this transformer? What action do I need to take? So basically what we do is we take smart meter data and aggregate it at the transformer level and make some decisions. But really where I see this going is if we incorporating weather response functions into our transformer load management system to say, or process to say, hey, if it's 102 degrees, what transformers are actually going to be overloaded, so we can get a lot more, not become quite as reactive and be much more proactive. The final one here is load studies, and this is more of something we have to file every time we have a rate case from our regulatory body, which is the Public Utility Commission of Texas. So basically, we have to provide interval data from up until the previous rate case at a class level. So for each different rate class, we need to provide an aggregate by 15 minutes what was consumed. And what they're using this data to do is to allocate costs. So previously, this was there was a bunch of estimation that was done, a lot of sampling to get to this point. But now that we have smart meters, we're able to get much more precise and really allocate cost appropriately, or at least allow the Public Utility Commission to do that. So outside of HDP, or I should say outside of analytics, what are we doing with HDP? Well, this is another initiative that we just finished design and we're going to be implementing. It's actually going right now. And there's two main sections of this. It's really, we're trying to create a document storage, both for historical invoices, and what this is we have a bunch of invoices generated out of SAP, and we are moving them using Scoop to Hive, and we're storing the blobs there. The way we're tackling this is by using the number of mappers to control the blocks, the file size, to make it closely aligned with the HDFS block size. Because a lot of these files are very, very small. They're less than 100 kilobytes. So we don't want to create too many files and overload our name node. The other portion of this, I also should mention that we also have an API on front of this where we need to be able to deliver this in sub-second response times. Because we're going to be ultimately integrating this with a lot of different applications, such as CRM. The other main section of this is the historical. We're currently migrating off our mainframe, thank gosh. But the business users can't give up their reports. So what we're doing is we're converting QCM and VCM files into text files, and then we're storing them as blobs within Hive. And this one's a little bit different since it's a one-time migration. We can afford to load the data in batches, so we're not overloading our name node. And because once again, these are very small files lots of times. Sometimes they can be in the megabytes, but generally they're below 100 kilobytes. So we want to be cognizant and not overload our name node. And once we get the files, or get everything into a Hive, we run compaction to decrease the file size and kind of combine multiple files into one. So I wanted to leave kind of ample time for questions. So Kenneth, if you want to come back up. If you have any questions for Kenneth and I, feel free to shoot. Yes?
Do you have any slide on how was your cluster built
On what?
Cluster sizing?
Yeah, it's 24 nodes for production right now. I can't hear you.
The hardware spec.
The hardware spec?
Who's asking?
Ooh. I'll have to get back to you with that. Honestly, I don't remember that off the top of my head. Yes?
I'm curious what the timeline looked like for some of your use cases that you talked about.
Right. So for specifically the smart meter one, we implemented that last year. That project, the HANA portion took about 7 or 8 months, and the HDP portion of it was much quicker. I mean, the majority of that was the design and implementation. So it was about 2 months, but a good month of that was just moving data from our historical Netezza appliance to HDP. So we actually tackled that probably because we were a little bit more comfortable. Our Netezza appliance was in a star schema model, and we kind of flattened it out when we went to HDP. So we did that unwinding in Netezza because we were more comfortable with it at the time. So that probably added a little bit to our timeline, but we kind of felt more confident because this is ultimately data accuracy is key here. So we wanted to make sure that everything kind of would correlate at the end and align.
Do you do any push down into Hadoop and like HANA and Hadoop working together, and how do you use Vora or anything of that sort?
Yeah, I didn't want to get into Vora because this is maybe a Hadoop conference. But yeah, we are using Vora, but we implemented an older version, 1.2, and the biggest struggle for us was our tables. The majority of them are very large, specifically for interval data, and you can't load it all into memory. So the version of Aura that we implemented doesn't allow you to bring in specific segments. You kind of have to bring in the whole table. So this is something that if you look at some of the newer versions of Aura, they have disk-based, and they also have the ability now, or well, you know what, I'm going to bite my tongue on that because I'm not sure how much that's public knowledge. But there's some new functionality that's coming out that's going to allow us to tackle this a little bit better.
Got a question for you. You talked about earlier about the forecasting model. Can you talk about a little bit about what are you using? Is it Spark? Is it something else?
Right. So, well, originally it's a combination. We're doing some stuff in HANA and we're doing some stuff in Hive as well. So it's a combination of both. But really, that's something that we've prototyped. We're going to be implementing most likely next year. So it's a kind of a next year use case. We're really just kind of laying the foundation right now.
How many meters do you have on this cluster? You said about 24.
It's 2.4 million smart meters.
2.4 million.
2.4 million.
24 node cluster for just the Hadoop, right? It's a 24 node cluster, is it?
Yeah, it's a 24 node cluster.
Okay.
2.4 million. And honestly, we have a lot of capacity to grow in there as well. So it's.
Hi. How important is data quality in your organization, and do you guys have anything implemented on a regular basis to analyze the quality of data and cleanse data, et cetera?
Specifically on smart meters, it's very, very, very important because it's something that we have to file, like I mentioned, from a rate case perspective. So yes, we have automated processes to compare data to make sure it got into HANA properly and also to make sure it got into HDP. So we look at not only record counts, we look at interval values. We sum those up as well. And it's something that we have to continuously monitor. We kind of get alerts when some things don't look proper. But yes, was a big chunk of that project was data quality.
Hi. What kind of reporting or BI tools you are working with to report from the cluster?
It's mainly business objects and Tableau. Tableau is obviously more. We're trending in the direction more and more of self-service reporting for our clients that want it. So we're leveraging Tableau for that, and business objects more for CAN reports like Webby, Design Studio, stuff, Lumira a little bit. So it's more of a for users that are a little less mature and don't really know their data. But for users that do, we really want to transition to self-service.
So related to Lumira, are you attaching directly to HTTP?
Yes.
Repeat the question, just please.
Are we attaching Lumira to HDP? And yes, it's just a simple ODBC.
Were you able to correlate a reduction in customer calls as a result of these smart meter use cases being taken live?
Well, I mean, for smart meters, it was, honestly, I'm probably not the best person to answer that question, but a lot of it was more on automating. You know, we don't have to roll a truck, right? Anytime we want to disconnect and reconnect a customer. So a lot of that gets more automated, but that's more, you know, the reps are what generate that. We have a whole transaction flow from our retail electric providers directly to us to say that, hey, you know, we want to disconnect this customer, and we can automatically do that now. So the big advantage for us was, you know, a reduction in truck rolls.
So are you doing any kind of analytics or any kind of determination with respect to momentaries and sags and swells in the Hive layer, or it is done already the SAP HANA layer?
I'm sorry, can you repeat?
The momentaries and the sags and swells using the meter events and meter readings, right? So that determination, more analytics, is being done on the Hadoop and
we're doing it a combination of both. It depends on where the data resides, right? So we're fortunate enough to where the majority, at least from a smart meter perspective, you know, you don't really, you look at data for maybe a year at a time or 6 months or individual customers. And if we do need to mash them up, yes, we can mash them up. But we're kind of fortunate enough to where we can kind of break them up for the majority of our use cases. But yes, we do mash them together, and we can mash them together in HTTP.
Okay.
Not fully, yeah, that will be at a customer level.
My question is with regards to, you said the title saying pouring the foundation kind of implies that this is the beginning, something is coming. Could you paint a picture of what is coming and maybe what is the utilization that you have on your current 24-node system?
Right, so really, like I said, I mean, the forecasting model engine, that's exactly what's coming, and really improving diversion. Those are at least around 2 specific use cases that we're trying to tackle in the near future. So this is kind of laying the foundation for both of those. That's really been prototyped. You know, FME still really need, the forecasting model engine still needs to really be designed more heavily, and Diversion is a project that's kicking off pretty soon, but that's, once again, something that still needs to be designed. So we just wanted to lay the foundation for both of those projects and eventually be able to support other use cases.
Thank you.
I have 2 follow-on questions from the previous one. You have 2.5 million meters. How big is your data size? I mean, in terabytes?
Yeah, once you get to about 10 years, it's about one petabyte.
But let's say 13 months, you said, you know, after that you're going to transition that to the Hive. What would be that size? 1 year worth of data?
1 year of data in Hive? Well, you just divide petabyte by 100, or by 10 rather. So, and it really depends on also what system you're storing it in as well.
Yeah, but I know you don't want to get into the cost and the HANA and all that, but what would you think the size of, you know, the cost of your solution is, just a number?
From a HANA perspective,
the overall, you know, to put together this is a software as a service model that you're offering, or?
No, it's something we've implemented.
Yeah, but
we custom developed it.
Solution, you think?
What?
What is the total cost of the whole solution that you put together?
I don't know if I really can divulge that number. So.
Quick question about your the utilization of HANA. We have a similar environment where I work as well. The storage growth in HANA, the licensing costs are outrageous, and so I'm kind of interested in what made you go with moving forward on saying, okay, 18 months of data within, or what, I can't remember the months, but within HANA, and then moving it over into Hadoop.
Yeah, we bought in real early on HANA, so our CIO signed a really great deal for us way when HANA was in its infancy. So we kind of have a luxury that a lot of companies don't have, where it doesn't cost us quite as much. We had a license where we could go up to 40 terabytes, and it's the same as if we paid for 2 terabytes. So we kind of, I guess, got lucky from that perspective. But really the main thing the reason we put a good chunk in HANA and another kind of tiered off into HTTP was just we felt, you know, that comfortable that we'd be able to handle the large number of updates that consistently come in. It's thousands of updates every time we read in. So we weren't quite sure we were going to be able to handle that in HTTP. Well, yeah, size and cost. I mean, we can't store everything in HANA or Netezza or really any other appliance. So yes. So is there any limitation on the type of analytics you can do on HTTP? Not that I've seen yet. So is there any plan to gradually get off HANA? Well, like I said, there's a large number of updates that are handling. So analytics and kind of getting the data in there, it's a little bit different. So we haven't tested out doing thousands and thousands of updates within HTTP yet. So we've done some preliminary stats without performance tuning, and I don't think that we'd be able to accomplish that yet. But you know, I'm sure Hortonworks may argue with me on that. I don't know, but that's just to be full-fledged honest.
Yeah, hi. You said you don't want to stress the name node with too many small files.
Right.
So you said you're combining them. Like, what kind of tools you use to, you know?
Well, we're using compaction, and then for Scoop, the number of mappers controls what the actual file size that's written in. So we kind of tested that out.
So is that like a daily compaction that's happening?
Yes.
Like a daily job or something?
Yeah, it will be. So that's one we're also in the process of implementing right now. But yes, it'll be a daily compaction. Well, I should say, it's not that process particularly is on it's kind of a one-time load. So we're kind of breaking it into chunks, and then we're running the compaction. If it was a daily process, that would be a different story. We haven't had to tackle that yet.
Okay. And also for your HTTP component itself, like, do you use like all the services or just use like Yarn, HDFS, Hive?
Right now, we're just using Yarn, HDFS, Hive. We're using Ranger for security, and we've Kerberized our environment. We've implemented Knox, but really a good chunk of the HTTP stack, but we haven't ventured out into HDF or anything like that yet. So.
Thanks.
Thanks. Could you give me an opinion about how successful your diversion investigations have been? Do you regard them as a success? Your diversion?
What about it?
Your analysis, do you regard it as a success? And how mature is that project?
So right now, yes, I would consider it a success. It's something that's it's in production today, and we are, fairly accurate on predicting diversion, but we think that using smart meter data is how we can greatly improve it, right? So it's the better accurate. I don't want to roll a truck. I mean, we're about 50-50 right now. So that's not great. We want to improve that. We want to get closer to 80-90%, because we're rolling too many trucks from that perspective.
Yeah. And just quick follow-up. Would you be prepared to share what your estimate of the percentage of energy is being diverted at the moment, or is that confidential?
So I'm going to say it's confidential because I'm not honestly 100% sure whether I can share that or not. Okay. But one thing I will say is I don't think we fully know how much energy is being diverted.
Okay, thank you.
Yes, you talked on one of your previous slides about an API strategy to help with the performance. Could you mention a little bit about kind of what you're doing and what you're looking at with that?
Well, are you talking about from the PDF documents, or? Yeah, so we've just developed it's just a simple .NET API right now. It's something that will, and honestly, we didn't really have to do anything robust. We were getting sub-second response times very easily, just mainly controlling that by partitioning the data by month for those PDF invoices. It's about 3.5, or eventually we'll grow to 5 million PDFs per partition, and we've been able to tackle that very easily.
So I think we're about to get kicked off the stage. So you can obviously have a one-on-one conversation with Daniel if you have any other questions on the way out. But we appreciate you taking the time to come over. Thank you for attending DataWorks, and have a great rest of the conference.
Right. Thanks, guys.